Good morning, everyone. Today I am going to explain Chomsky hierarchy focusing on type 0 and type 1 grammar. This topic is part of automata and compiler design. The Chomsky hierarchy helps us understand different types of formal grammars and their power in language processing. Coming to Chomsky hierarchy. The Chomsky hierarchy was introduced by Noam Chomsky in 1956. It classifies formal grammars into four types based on the production rules. Type 0 is also called as unrestricted grammar. Type 1 is also called as context sensitive grammar. Type 2 is also called as context free grammar. Type 3 is also called as regular grammar. As we move on from type 0 to type 3, the power decreases. Type 0 is most powerful while type 3 is most restricted. And coming to the hierarchy. This diagram shows four levels of the Chomsky hierarchy. At the top is type 0, which is most powerful grammar. Then comes type 1, type 2, and finally type 3, which is the least powerful. Each lower level is a subset of the level above it. That means every regular grammar is also context free, every context free language is context sensitive, and so on. Now, coming to the topic, type 0 grammar. Now, let us look at the type 0 grammar, also called as unrestricted grammar. In this grammar, there are no restrictions on the production rules. The rule can be written as alpha produces beta, where both sides can be any string of terminals and non-terminals. Type 0 grammars are recognized by a Turing machine. They generate recursively enumerable languages, which means they can represent any language that can be computed. This makes type 0 the most powerful grammar, but it is difficult to implement in practice. So, next coming to type 1 grammar, also called as context sensitive grammar. In this grammar, the production rules depends on the surrounding context of a symbol. The length of the right hand side must be greater than or equal to the left hand side. This means the string cannot become shorter during derivation. Type 1 grammars are recognized by linear bounded automata. They are more structured than type 0 grammars. A common example is in the language A power n, B power n, C power n, where the number of A's, B's, and C's must be equal. Now, coming to the comparison of type 0 and type 1. The slide compares type 0 and type 1 grammar. Type 0 grammar has no restrictions, so it is more powerful. It is recognized by Turing machine. Type 1 grammar has restricted rules, so it is less powerful than type 0 but more practical. It is recognized by linear bounded automata. So type 0 is more theoretical, while type 1 is more useful for structural language processing. So now diving into applications. Now let's see the applications of these grammars. Type 0 grammar is mainly used in computability theory in understanding the limits of computation. It is the basis of Turing machine models. Type 1 grammar is used in natural language processing, compiler syntax analysis, pattern recognition, and structured data validation. A simple analogy is like type 0 is like a free system with no rules, while type 1 is working within guidelines. Coming to the conclusion, type 0 grammar is most powerful grammar with no restrictions and it is recognized by a Turing machine. Type 1 grammar is more structured, follows context-based rules and it is recognized by linear bounded automata. Both grammars are important in formal language theory and compilism. Understanding this hierarchy helps us design better programming languages and efficient compilers. Thank you.